When it comes to scientific advancements, vaccines are among the most notable. They're very commonplace in our lives today and have recently gained a lot of attention thanks to the rollout of vaccines against COVID-19. However, vaccines and the science behind them are nothing new, as the idea goes back hundreds of years. The concept first gained major traction in the world following the efforts of a scientist named Edward Jenner in 1796. Now, at the time, smallpox was in full swing. However, dairy farmers never seemed to become sick with it. Now, Jenner observed that these farmers worked very closely with cows that often were infected with cowpox. Believing that cowpox exposure was the key, Jenner performed a test where he infected an 8-year-old with cowpox, let him fully recover, and then infected him with smallpox. The experiment worked, and the boy was protected from the deadly disease. As a result, a true smallpox vaccine was developed in 1798, and by 1980, the world had fully eradicated the disease. Now, Jenner's vaccine design of using one disease to protect against another is but one of many different types. You can use heat to inactivate or kill your pathogen of interest. You can also use its genetic material to vaccine with. Now, all of these different designs, however, share the same basic components. Something specific to your pathogen, called an antigen, and something to activate your immune system, called an adjuvant. Now, the adjuvants currently used in vaccines work very well. However, anytime a new adjuvant candidate is introduced, it has to be both safe and effective, which takes time to validate. Therefore, developing new vaccines has this issue of a limited pool of new adjuvants. But what if I told you that a solution to this problem exists, and it can be found naturally in the world? That's where saponins come in. Derived from the bark of South American trees, these are proteins that have recently been characterized as safe adjuvants. Now all they need is their effectiveness confirmed, and our lab has been hard at work trying to do this. When we perform our tests, we hope to see the release of a specific type of protein called cytokines by cells that we expose our saponins to. If we see more cytokines, that means the immune system is more increasingly activated. And therefore, if we see higher cytokines after exposure, that saponin works well. Now, we're still in the process of testing our stock of saponins. However, I am happy to say that we have found some that do result in increased cytokine release. We're very excited about this work as it has the potential to expand the pool of safe and effective adjuvants and thereby making development of new vaccines all the easier. Thank you.